This is part 2 of lesson 9-2. Today we're going to focus on solving logarithmic equations and inequalities. So here's example 1. Solve each equation, then check your solutions. The equations that we're going to work on in this section have logs on both sides with the same base. So pretty simple equations to solve. If the two sides of your equation have the same base, you can set the rest of the log equal to each other. So here's kind of one thing that I just do. Since both sides are log base 5, you can cancel out log base 5 and set p squared minus 2 equal to p. In order for both sides to be equal, it makes sense that these two parts have to be equal because we want the same log on both sides. So now what we have here is a quadratic equation. I would set it equal to 0, so I'm going to subtract p on each side, and I get p squared minus 1p minus 2 equals 0. Now this one does happen to factor. Can you think of two numbers that multiply to -2 and add up to -1? Well, it's going to be p minus 2 times p plus 1. So you've got your two factors, and now you can set each factor equal to 0 to find your solutions. P minus 2 equals 0 and p plus 1 equals 0. So that must mean that p equals 2 and p equals -1. Now, we're not really guaranteed today, we're not really guaranteed that these are solutions. They could be extraneous, and the reason is when you're solving these log equations, your domain is not all reals. Remember, our domain for these log functions was from 0 to infinity. So unlike exponential functions where we didn't have to really check our answer, any number would work that, that we would get for a solution. It is possible here to have some numbers that we get when we solve the equation, but they could be extraneous, meaning they actually result in an undefined answer. So let's check 2 in our log function here. If I plug in 2 squared, that's 4. 4 minus 2 is 2. So that's log base 5 of 2 equals the log base 5 of 2. 2 actually works. That's okay. You might also say that -1 works when we plug it in, but there's a problem with plugging in -1 here. You cannot take the log of a negative. So over here, if I plug in -1, -1 squared is 1. 1 minus 2 is -1. Over here, I get the log base 5 of -1. The log of -1 doesn't exist. You cannot take the log of negative values because our domain is from 0 to infinity. So p equals -1 is out. It doesn't mean that all negative solutions are out, but in this case, plugging in a -1 results in taking the log of -1, and that's not going to work. Okay, so -1 is extraneous, but 2 is a solution. Now let's see how this one goes. So again, on each side, you're going to notice that the bases match, and that's kind of what we need in order to solve these. So log base 3 of x squared minus 15 equals log base 3 of 2x. Cancel out your log base 3 on each side and set x squared minus 15 equal to 2x. Again, we're going to have a quadratic equation here. I'm going to subtract 2x on each side so that I can get it into quadratic form here. X squared minus 2x minus 15 equals 0. This one also factors. My two factors are going to be x minus 5 times x plus 3. If we check it quick with FOIL, you can see that it works. X times x is x squared. You'll have a positive 3x minus 5x and then minus 15. Okay, so all the terms are there. All right, now let's set each one equal to 0 and we can find our solutions. So the first solution is x equals 5. We'll check it in a minute to see if it works. In our second solution, x plus 3 equals 0. That means x equals -3. So if I plug in 5, well, both of these logs have a positive value here. So 5 squared is 25. 25 minus 15, that's 10. Positive 10, so that's good. And over here, 2 times 5 is 10. Good, those match. So 5 is a solution. But if I plug in -3, you can see it right here in this one. 2 times -3 is -6. And the log base 3 of -6 is undefined. We can't take logs of negative numbers. It's not in the domain. So again, you've got an extraneous solution here, and 5 is the only one that we're going to take. Okay, moving on to the inequalities. Log inequalities, they're inequalities that involve logarithms. They're going to be set up the same way that those equations were, but we have one extra step here. So step number 1, we're going to solve the inequalities the same way that we were just doing them, basically by canceling out the log on each side. But in step 2, because these are inequalities here, we are going to have to exclude values that would result in taking the log of a negative. So here's the first problem. Notice that we've got log base 10 on each side. We've got 3x minus 4 is less than x plus 6. Let's cancel out our logs. 3x minus 4 is less than x plus 6. All we need to do here is solve it for x. I'm going to take away an x on each side so that I get 2x minus 4 is less than 6. Then I'll add 4 to each side. 6 and 4 gives me 10. Divide each side by 2, and I get x is less than 5. Now, if you think about your number line here, x is less than 5, so we're not including 5, but I would be kind of shading to the left here. My solution set is any number less than 5. But wait a minute, I can't plug in any negative I want to here because we can't take the log of a negative number. So here's your step 2. Here's the next thing you need to do. At some point here, we're going to have to cut off these values. I can't plug in anything less than 5. I'm going to have to draw a line there. So on the left side, we're taking the log of 3x minus 4. We can only take the log of positive values. So the next step, the next thing you need to do is say that 3x minus 4 has to stay positive. It has to stay greater than 0. On the right side here, you're taking the log of x plus 6. This also has to stay greater than 0 because we can't take the log of negative numbers. So you kind of have 2 more little problems that you need to solve. So let's go ahead and figure out what these values are. 3x is greater than 4. X has to stay greater than 4/3 in this case. Over here, x has to stay greater than -6. Well, I can't really go all the way out to -6 because of the left side of my equation. So x has to stay greater than 4/3, so that means at 4/3 or 1 1/3, that's where I need to cut off my solution set. So your solutions are going to be just in between 4/3 and 5. If you want to write it in interval notation, you certainly can, 4/3 to 5. You could write it using inequalities. X is in between. X is less than 5 and greater than 4/3. That's another way to write your solution. Okay, so when you're solving the inequalities, you'll drop the log on each side, solve it like you normally would. We got x is less than 5. But you need to go beyond that. You need to set each log greater than 0. Okay, now we got x is greater than 4/3 and x is greater than -6. This -6 though doesn't really matter because you got to pick the one that's furthest to the right. 4/3, positive 4/3 is where we need to cut off our solutions. Let me show you one more of these. So the log base 5 of 2x plus 1 is less than or equal to the log base 5 of x plus 4. So step number 1, I'm just going to solve the log inequality. I'll drop the logs on each side. You can do this as long as the bases match. And we'll set up the inequality 2x plus 1 is less than or equal to x plus 4. Let's go ahead and see what we get for x. So I get x plus 1 is less than or equal to 4. I'll subtract 1 on each side. Then I get x is less than or equal to 3. Okay, that's part of my solution definitely, but I can't plug in any number less than or equal to 3. At some point, these x values need to be cut off here. So now your next step is to take each log and set it greater than 0. 2x plus 1 cannot be negative, so I've got to set it greater than 0. And x plus 4 also needs to stay greater than 0. So in this first part, we're going to get x is greater than -1/2. Okay, that's great. I'm going to put -1/2 here on my number line. Over here, I'm going to get x has to stay greater than -4. Well, that's way back here. -4 is way back here. I don't really want these values. I got to cut them off here at -1/2. And you can use an open dot on this point here because we don't want to be equal to 0, but we want to be greater than 0. So use an open dot on this endpoint, but a closed dot on this endpoint because the original problem had an equal to underneath it. So your solutions go from -1/2 to 3. I like to use interval notation because I just think it's easier. So I've got -1/2 with a parenthesis to 3 with a bracket. Those are your solutions. Anything in here would work. An easy way to test that would be to pick a number in your solution. We could pick 1 and see if we get something that's true. Okay, that is it for today. We'll practice some of these in class and then we'll move on to some other stuff tomorrow.